Okay, good morning, good afternoon, good evening, good night, depending on when you're watching this video. So in this video, we are going to be working through the exercises on slide 27 of lecture set number 5. At this point, we have seen, or we should have seen, illustrations of how to find area underneath a standard normal curve. In these two exercises, we will be going in the opposite direction. So we will be finding a z-score given the area. Now, in order to find the z-score given the area, we have to have an area to work with. You'll notice that in this exercise, we have two values, z subscript 0.05 and z subscript 0.06. The subscript represents the area to the right of the z-score of interest. Okay, so for example, so this whole thing is what we're looking for. This is one number. Okay. So we start by sketching our standard normal curve. Okay, so we have our standard normal curve. It's centered at 0. On each side of 0, we have 0.5% of the area. Okay. So the z-score that we're looking for is telling us that to the right of this value, there is 0.15 of the area under the curve. Okay, so that means that our z-score is going to be located on the positive side of 0. Because if there is only 0.15 to the right, that means that the value is not, or that the area is not large enough that you would cross to the negative side. So essentially, any z-score whose subscript is bigger than 0.5 will be a negative value, and any z-score whose subscript is less than 0.5 will be a positive value. Okay. And if the z-score has a subscript equal to 0.5, it's equal to 0. Okay. Z subscript 0.5 equals 0. Okay, so the z-score we're looking for has 0.15 of the area to its right. So that means that this red shaded part here is size 0.15. So we are looking for the z-score that has 0.15 of the area to its right. In order to find this value, we calculate the area to the left. The reason we do this is because every standard normal table gives you area to the left by design. Okay, so the z-score with 0.015 is going to have 0.85 of the area under the curve to its left. Okay, so this whole region here is going to be a size 0.15. And I'll just highlight that in green to make it more clear. Okay, so this green shaded part is a size of 0.85. And we know that that's true because the sums of the z-score, the sums of the area under the curve around the z-score have to equal 1. So 0.85 plus 0.15 equals 1. All right, so now what we're going to do is we're going to look up 0.85 in the standard normal table. Right, so we go to our standard normal table. Right, so if we start on the negative side, you can see that this gives us area up to 0.5. So the maximum area here is 0.5. So we have to go to the positive side to keep looking for value. Okay, so as we scroll through the positive side, okay, we're looking for 0.85, which we can see there are two options, 0.8485 and 0.8508. Since 0.8508 is closer to the value than 0.8485, we'll just take that value. Okay, so in any situation, if you don't find the area you're looking for exactly, you can just choose the closest number. If the area happens to fall directly in between two values in the table, then you have to average the z-score. But this only happens in two situations. When you're looking for an area of size 0.1 and an area of size 0.01. Okay, so now we come out to the axes. Okay, so we come out to the axis this way to get 1.0, and we come out to the axis this way to get 0.04. Okay, so this means that the z-score that has 0.15 of the area to its right is 1.04. Okay, so this thing here is 1.04. Okay. So therefore, z subscript 0.15 is equal to 1.04. All right, what happens if we accidentally look up just 0.15 directly in the table? All right, well, if we went to our negative side and we said, and we forgot to subtract from 1, and we just looked up 0.15, what we should find is that the closest we can get to 0.15 is right here, 1.492. Okay, so if we go out to the axes, we can see that this gives us negative 1.04. So it's actually the exact same value. All right, so if we look up 0.1500 in SNT, we get z equals negative 1.04. So we can see that the magnitude of the values is exactly the same, but and we can use this as long as we realize that any z-score with a subscript bigger or less than 0.5 has to be positive. So if we just knock the positive off of this, we can also get the right answer. Okay, so this is why it's important that we sketch what we're looking for so that we don't make a mistake when we are trying to find these values. All right. Okay, so now let's look for z subscript 0.6. Okay, so we want to find z subscript 0.60. So we start by sketching out our normal curve. Here's our curve centered at 0. Okay. All right, so in this case, we have 0.6 of the area to the right of the z-score. So this means that we're now going to be working with a negative z, or we're looking for a negative valued z-score. So we're going to mark our z-score down on the negative side of the curve, so left of 0. So this is what the z-score is telling us. Okay, so this is a size 0.6. Okay, so if we have 0.6 to the right of the z-score, that means that to the left of the z-score, we have 0.4. So now what we're going to do is we're going to look up 0.4 in the standard normal table. So we go to our negative our negative page. Okay, we know the z-score is going to be negative because the area to the right is bigger than 0.5. Okay, so 0.4 is closest to this value here. So 0.4013 is closer to 0.4 than 0.3974. Okay, so this is the area. And then it means that our z-score is going to be negative 0.205. Okay, so therefore z subscript 0.6 equals negative 0.25. Okay. And then again, what happens if we looked up 0.6 directly in the table? So if we go to the positive side, we look up 0.6. Okay, the closest we're going to get is 0.5987. All right, what's going to happen if we go to the axes here? We're going to get 0.25. But we have to remember that we have to convert this into a negative because that tail area to the right is greater than 0.5, which means that the z-score has to be a negative value. So we can use the positive side and just remember that we need to put the negative in front because any z-score with an area greater than 0.5 to its right has to be a negative value. Okay, if you have any questions, please let me know.